If the second derivative test fails to identify the maxima or minima, we are to use the first derivative test. You are in differential calculus. How do we look for the critical points? Having a given function, take the derivative in order to have the slope. And from the highest or lowest points, the slope is 0. Equating the first derivative to 0, we can look for x. So to complete the critical point, substitute x into the original function to have y. Learning about the critical point, next is to categorize if it is the maximum or the minimum point. That is by looking for the second derivative of y, and then check if y double prime is negative or positive. If it is negative, the critical point is a maxima, or the highest point. And if y double prime is positive, then the critical point is the lowest, or the minima. The fifth example consists of the function 9a cubed y is equal to x times the cube of the binomial 4a minus x. First is to locate the critical points. If we opt to differentiate an explicit function, 9a cubed is placed to the right expression. But since it is considered a constant, the differentiation will only cover x times the cube of 4a minus x. There are different ways to differentiate the function. The first option is to keep the function as it is. And having two terms, the differentiation can be done using power rule. With the constant brought out, y prime is 1 over 9a cubed. Then with power rule, the function becomes x times the derivative of the cube of 4a minus x. Then add the second term multiplied by the derivative of the first term x. Dx over dx is 1, simplifying the last term. Working on the derivative from the first term, y prime is 1 over 9a cubed with x times 3 with the square of 4a minus x, then attach the derivative of 4a minus x. Simplifying the derivative of 4a as 0 and the derivative of negative x as negative 1, y prime then is as shown, which then becomes 1 over 9a cubed times negative 3x with the square of 4a minus x plus the cube of 4a minus x. With the two terms having a common binomial of the square of 4a minus x, extract it out with a constant, making the remaining part of the expression negative 3x plus 4a minus x. Since y prime is equated to 0, cross-multiplying 9a cubed still gives 0. The binomial on the right is also simplified into negative 4x plus 4a. With a pair of binomials equated to 0, we can take them out individually. That is 4a minus x squared is equal to 0, and negative 4x plus 4a is also equal to 0. From the left, x is 4a, and having this as repeated to account for the square. For the right function, transpose one term to the right and have 4x as equal to 4a. So the third value of x is equal to a. Another option in differentiating the function is to expand it first before differentiation. If the cube of the binomial is expanded, the included coefficients are 1, 3, 3, and 1 using Pascal's triangle. Simplifying each term, there are 64a cubed, negative 48a squared x, 12a x squared, then negative x cubed. take out groupings, so distribute x among the terms. The terms are now easier to differentiate, making 64a cubed times d over dx of x minus 48a squared times 2x with d over dx of x. Then the third term is 12a times 3x squared with d over dx of x minus 4x cubed times d over dx of x. Y prime is equated to 0, then dx over dx is 1. The function is then simplified as 0 as equated to 63a cubed minus 96a squared times x plus 36a with x squared minus 4x cubed. Factoring out 4 per term, the function becomes 0 as equal to 16a cubed minus 24a squared x plus 9a x squared minus x cubed. With a cubic polynomial, we can solve for the terms by employing synthetic division. Try x of 1 as divisor, and synthetic division starts with dropping down the first term, negative 1. Then multiply 1 and negative 1, which is negative 1, placed on the next column. Now 9 minus 1 is 8. Then again 8 times 1 is 8 placed onto the next column. So negative 24 plus 8 is negative 16. Then negative 16 times 1 is negative 16. So 16 minus 16 is 0. The remaining coefficients are negative x squared plus 8x minus 16 as equal to 0. Extracting out the negative sign, the function becomes x squared minus 8x plus 16 as equal to 0. This function can then be easily factored as x minus 4 with another x minus 4. Thus, x is 4. So from the function, there should be a, so the repeated x is actually 4a. Then the other x is 1a or just a. After identifying the x values, we can then solve for the y coordinates of each point. With x of a plugged into the original function, we get 9a cubed y as equal to a times the cube of 4a minus a, which is simplified as 3a. Simplifying the right term into 27a raised to 4. Y is then 27a raised to 4 over 9a cubed, so y is 3a, and point 1 has coordinates a, 3a. If x is equal to 4a, 9a cubed y is equal to 4a times the cube of 4a minus 4a, which is 0. So 9a cubed y is 0, and y is equal to 0. So point 2 has coordinates 4a and 0. Learning the critical points, identify which is the maxima and the minima. From the slope equation, differentiate it again to have y double prime. The first term is then 0, and the second term is then negative 24a squared, with the derivative of x. The third term is 9a, with the derivative of x squared, which is 2x. Then attach dx over dx. The derivative of the last term is then negative 3x squared, with the derivative of x with respect to x. Again, dx over dx is 1, giving y double prime as negative 24a squared plus 18ax minus 3x squared. From the first point where x is a, y double prime is negative 24a squared plus 18a times a minus 3 with the square of a. Y double prime is negative 3a squared. Having y double prime as negative makes the first point as a maxima. The next is x as 4a. y double prime is negative 24a squared plus 18a times 4a minus thrice of the square of 4a. Y double prime is then negative 24a squared plus 18a times 4a minus 3 times the square of 4a, which then becomes 0, which means the test fails for the point. Use the first derivative test for the second point. Draw the critical points. Those are at x as a and 4a. Since we are focusing on x of 4a, focus on the left range of 4a and assume x of 3a. Using the slope, plug x of 3a in the y prime function, which becomes 16a cubed minus 24a squared times 3a plus 9a times the square of 3a minus the cube of 3a. Y prime is then negative 2a cubed. Being negative, the curve starts from top left and slides down to the right. For the right range, assume x of 5a. And using the slope equation, we get 16a cubed minus 24a squared times 5a plus 9a times the square of 5a minus the cube of 5a, which is simplified as negative 4a cubed. Since this is also a negative, the curve continues from top left and slides down to the right. Having this as the trend of the curve, point 2 is not an extreme.